Okay. Hi guys.
Good evening, sir.
Good
Team.
evening.
Good evening, sir.
Good evening.
So all of you are ready? I think after a long time we are meeting. I'm not sure like when we last were here, but fine. So
Yes,
today
sir.
is week 11.
Yes, sir. Long time no see.
Yeah. Okay. So yeah. Okay. Then it's fine. Let's start. Before starting this, I wanted to know what you have studied from week 11 until now, or like what is it? How was okay? First of all, tell me all of you, how was your quizzes, quiz one and quiz two results? Quiz two, how was it? First of all, let me know that one.
Sir, great.
Good, sir.
Good.
Very good.
Fine.
Great.
Okay. Okay. Fine.
Sir, just passed.
Just passed. Okay. What was the problem? Any issues
Difficult
like
to PNC.
P
Some
and C? Okay.
Sir, CT was I was not able to understand.
Which one?
The
Okay, CT. Okay. No, no. I was talking about majorly about statistics. So that
PNC, sir.
PNC was a problem.
Yes, sir. PNC, there was a lot of confusion in the questions.
Okay. Okay.
I am getting confusion in the ring-like problem anti-clockwise and clockwise.
Hmm. Okay. Circular permutations. Okay.
Yes, the circular promoters.
Okay. Any other issues? Okay, most majorly that thing, that part, right? So okay, let's
Yes,
see
sir.
if we get
Permutation and
some time
combination.
today. Maybe I'll try to solve some questions from quiz itself. If you want, at the end we'll try to solve. But for that, okay, you guys have solved it later on, like after quiz. Have you tried it? Did you understand where is your mistake or something like that?
Not getting much time for the question practice
Okay, fine.
after
So
qualifier.
okay.
we
So
are
that
doing another course as well, so it is becoming difficult along with
yeah,
college.
okay, fine.
Sir,
So
will
this
we
things,
have
yeah.
revision sessions for previous chapters or that
Hmm.
week 1 to week 10? Will we have revision sessions in the coming time?
We can have, it's not a problem. Like if you get time, we may have a quick revision session. Okay, but today what I'll do is maybe I'll start with week 11 and little bit I'll try to solve some permutation, because I understand like most of you are having difficulties in this problems, permutation combinations, or else like or any other difficulties there. Maybe I'll try to help you
Sir,
out.
But
conditional
if
probability.
5 to 8 you could revise. Sir.
Yes, sir.
basic
Conditional
Okay.
probabilities.
difficulty in
Sorry. Okay,
understanding
okay.
the
Just a minute.
questions.
Just a minute. Just okay.
Sir,
Okay, just a minute. Before I'm not going to, revise the entire content from 5 to 8. It will
sir,
take a
base
lot of time.
theorem, sir.
No, sir.
But if
Questions
today
are very
we finish
confusing.
the
Base
base and
theorem
then
बता
we
दो.
can finish.
Base.
Sir, the frequency of a statistics class is very low. Why, sir?
No, I think we are having like enough classes, right? We are having, and TA sessions are also happening.
Sir, they are
So
not allowing inside.
Yes, sir. TAs are not allowing the lectures.
okay, okay,
Sir,
fine.
none of the TAs in any subject.
No, no, I think some IDs are. It's not their fault actually. Some IDs actually are not. Before that qualifier, something happened, right? So that's why they are restricted. Some IDs are restricted. Fine. Let's do one thing. First of all, how much you have studied week 11? Let me know first. That first. I'll.
I
Sir,
was
Go through all the
lectures
PDF.
done.
Gone through this once.
Yeah.
Yes, but the
Okay.
concepts are not very much clear, sir.
Okay. Actually,
So Poisson's distribution is very confusing.
oh no, no. Okay,
Yes,
fine.
sir. I've also doubt in Poisson distribution.
So what I'll do is maybe without revising everything, what I'll do is maybe see what we'll do is we'll try to solve some problems. So if you
Yes, sir.
solve some problems, you may get a better understanding of it. So I'll just give you the glimpses of what are these. Actually, only three distributions we have studied here, right? In week 11, binomial, hypergeometric, and Poisson, right?
Yes, sir.
Yes, sir.
So let's talk about maybe I'll just share my screen. Okay.
First, we can just have a discussion in the concepts, then we can solve the
Yes, yes, yes,
questions.
yes. Yeah, so I'm not going into great details of the concepts because ma'am has covered, I think, a lot of theorems. She has I think she has proved a lot of theorems. I'm not going into that details. What I'll do is just basically write down the formulas and what is the basic understanding of each of the distribution, right? So quick revision of it. Then we'll
Yes, sir.
solve some problems in week 11, and then maybe I'll talk about little bit about permutation combinations, right? So yeah, let's do that first now.
They will
Yes,
be
sir.
discussing
Sir,
the
can you
content of
share
week
any
11 or
end
start
term
with it.
paper?
Sorry.
Can you share any end term papers previous year?
Uh, I think there those are available. It's not a
Sir, can you explain assumptions of Poisson's and its derivation
yep.
as well? Poisson
Derivation. See,
distribution.
I think again going into the derivations, right? It will like take a lot of time, right? So
At
we
least
have
assumptions.
assumptions and everything. I'll let you know. Poison, I will maybe I'll go somewhat deeper. Fine, that I'll do. But
Yes, sir.
see,
Yes, sir.
mostly to try to solve some problems, right? If you solve some problems, I think then it will not be that difficult, right?
Yes,
Understanding.
sir.
See, one thing is understanding through pure mathematical way, and another thing is try to solve some problems and try and understand about that concept through the problems, right? So we'll do that thing because ma'am has anyway covered everything in the lecture, so I'll just go through the questions and maybe wherever is the difficulty, just let me know and we'll stop and discuss about it. Okay. So yeah, first of all, let me start with. Did you have geometric distribution this week? No, right? No, right?
Hypergeometric.
Yeah, hypergeometric is there, but geometric it's not there, right? Fine.
Yes, sir.
Okay, no issue. So it will start basically from Bernoulli trial, right? Bernoulli trial. So and okay, first of all, we'll discuss about the random variable. What is random variable? Yeah, tell me.
Sir, it's a variable which is a real valued function of the independent sample space.
Okay. Any example of it? Let's talk about one.
Some of the outcome of two rolls in a dice.
Okay. Okay.
Let's
Let's take one simpler example. So let's say we have an experiment. Okay, experiment. What is an experiment or a trial? Experiment or trial. So let's say we tossed a coin. Okay, the simple experiment I'm going to take. What are the two outcomes here? Head and tail, right?
Tail.
And we'll define one sample space for this experiment, right? So let's say S, and what are the elements in the sample space? H, T. Okay, that's fine. Now let us define a random variable x such that uh, it will count uh, or what do you say, getting ahead, getting ahead or getting a tail. Let's say getting a tail in a toss, right? The toss of a coin. So this is my random variable, right? Okay, so tossing, let's say this is a fair coin. Tossing a fair coin, what do you mean by fair coin?
Unbiased.
Equal,
Chances
equal
of
probabilities, right?
yeah.
Yeah, equally
equally
likely
likely.
outcome. So that means the probabilities associated with these events is equal. So it is half and half because we know from the properties of probability that the sum of all probability should be equal to 1,
One.
right? Right. Right. So let's say this is a random variable x, and we defined a random variable such that we wanted to see a tail, right? We wanted to see tail in a coin. So let's assume, or let's represent two values, or let's assign two values to this random variable. One value is 1 and another value is -1. So 1 for success, okay, and -1 for failure, right? We can have any other value also. So we generally will have 0 as we'll assign 0 to failure, right? So what will be the probability mass function? So since this is a discrete random variable, why this is discrete random variable?
It's countable.
Huh?
Countable.
Yeah, so the outcomes of this random variable, right? So or you can say this random variable cannot take all the values between an interval, and these are countable. So let's say because we have only 0 and 1. So what is and for this random variable we define what? PMF. PMF is what? Probability
Probability
mass
mass
function, right?
function.
Probability mass
Mass
function.
function, right? Okay. So this is PMF for this random variable. What will be the PMF for this? So X will be taking two values, and that is called the range of the variable, right? 0 and 1. What is probability associated with uh, these values? What is this?
Half and
1
half.
by 2.
0.5.
Yeah, this is my PMF, right? So this is one of the example of random variable, and this is nothing
Sir,
but
sorry to disturb, but I think all this we already discussed, sir, in previous weeks.
yeah, fine. I understand. So I'm just making it for binomial, and then I'll go to hypergeometric, and then I'll move to this uh, because these are all related. That's why I'm just discussing it in a brief, right? So this is Bernoulli trial. So what is binomial?
Sir, it needs to be independent and another.
Binomial is independent.
Independent identical distribution.
Yeah. So which identical distribution we are talking about here?
Probability.
Bernoulli, right? So this is an IID example, right? IID means independent and identically distributed. What does that mean? So I'll tell you. So independent is what? Whatever happening in the next trial does not depend on the previous trial, right? So for example, you toss a coin for 5 times. So whatever outcome is you are getting in the second toss is not dependent on the first toss, right? Similarly, whatever outcome you are getting in the third toss is not dependent on the second or the first toss. So in another way, what is it? The probability of each probability mass function, right? Probability mass function is same throughout the trials. Understand? So each of the probabilities are not changing here. Probability of success is not changing here, right? So here the success was what? Getting a tail, right? So here in each of the trial, the probability of getting a tail is not going to change. Understand? So you just toss a coin for 5 times. In the first toss, the probability of getting a tail is not changed. In the second toss, it is again half. In third toss, it is again half, like that. So that is independent, or I
Same
can say,
probability.
yeah. So this is identically distributed, means each time you toss a coin, you'll have the same distribution, which is a Bernoulli distribution, right? In this case, so this is what binomial is, just a sum of independent Bernoulli trials, right? Sum of independent Bernoulli trials. So these are the assumptions here. That is what we are saying. Each of the trial is independent. Okay, and
Independent means they're not dependent on each other. Like,
yes, yeah, on the previous trial. The outcome of the second trial is not dependent on the outcome of the first trial, right? So that means if I'm getting head, uh, next toss getting a tail, it does not depend on getting a head. So sometimes there is this thing, right? And this can be actually understand by with replacement. Okay, this is called with replacement. How? I'll tell you. Suppose you have 3 blue balls, and let's say or 3 black balls and two white balls, okay, in a container, right? And I have chosen one ball randomly, and okay, so let's say I have defined one random variable x such that uh, I need a white ball, right? Need a white ball when I chose one ball randomly. So if I choose one ball randomly, what is the probability of getting white ball here?
2/5.
It is 2/5, right? And what is the probability of getting a black ball here?
3/5.
3/5, right? Right. So if I choose one ball randomly out of this container, I know what is the probability of getting white ball is 2/5, and getting a probability of black ball as 3/5. But suppose if I choose two balls from this container, what will happen? So first ball, if I choose first ball, what is the probability of that getting a white ball here?
2 by 5.
2 by 5.
2 by 5 for white ball, and for black ball it is 3 by
3 by
5. Okay. And what about second? If I give you that information, if I'll say
This is with replacement, right?
yeah, if I say without replacement, what will be the probability
B
3
by
by
4.
of getting a white ball?
1 by 4.
3 by 4.
1 by 3.
Sorry, 3 by 3.
1 by 4, sir.
Okay. Okay. Why? Okay. Now, why you are confused is because you need an information what happened in the first ball, right? What happened to the first ball? I need to know that what happened here. So in the let's say first ball is white ball, then the probability of the getting a white ball in the second. Okay. Maybe I'll write it the properly, right? So just say this was my container, right? 3 black balls and
So could you increase your volume?
oh, it's not.
It's very low.
Okay, is it fine now?
Yes, sir.
Yes, sir.
Okay, you just okay. So 2 white balls, right? So now my thing is I just so I said that it's without replacement. Okay, currently I'm saying without replacement, and I have chosen 2 balls randomly. Okay, randomly and not at the same time, one by one. Okay, so what is the probability of, and my random variable x is let's say, or okay, not random variable, just talk about the probabilities, pure probabilities here. So what about getting a white ball? What is the probability of getting a white ball here? First
2
ball
by
as
5.
2.5.
getting white ball as 2 by 5, and black ball is
3 by 5.
3 by
5.
4.
3
Okay.
by 5, right? 3 by 5. What
Okay.
about the second ball?
It
1
would
by
depend
5.
on the first ball.
Yeah, so this is without replacement, right? So I have already
Sir, 1 by
chosen
4.
one ball, and suppose my first ball is white, right? Then getting a white in the second ball
1 by 4.
will be equal to
1 by 4.
1 by
4.
4.
4. What about here? And getting a black ball
2 by 4.
3 by
3
4.
by 4.
3 by 4.
3 by 4. Here, what is the probability of getting white ball?
2 by
2 by
4.
4 and then 2 by 4
2
for
by
both.
4 and for black ball
Black
2
ball
by
also.
2 by 4, right? Okay.
Yes,
Now
sir.
what is happening here? This is probability of getting first white ball, right? Or first ball. So let's say if I define a random variable x as getting a white ball in. So if you see, these probabilities are changing later on, right? It depends on what, how I have chosen the first ball, right? So suppose my second case is like this: 3 black balls and 2 white balls. Now I am saying it's with replacement. What do you mean by with replacement? Once I chose first ball, I'll see the color and I'll keep that ball into that container again, right? So now tell me, if I select first ball, what is probability of getting white ball?
2 by
3
5.
2 by 5.
And black ball is
3 by 5.
3 by 5 again. So in the second, and now again, so I said it's replacement. So I have seen that ball and I have just kept it back again. What is the probability of getting second ball as white?
It
1
will
by
be
5.
2 by 5 and 3 by 5.
2 by 5 and right. This is an independent case, right?
Yeah.
And this is
So
dependent.
independent, sir, but also in the when there's a white ball set, the second ball can be either white or black, and there we need not have two cases.
Sorry, I don't
So is it
understand.
when there's with replacement, when doing the second time we need not have 4 cases?
Yeah, okay, fine. Okay. Yeah, this cases you are talking about, right? Yeah, you need not to have, right?
Yes.
That's why this distribution is same, right? You're understanding my point. This is the distribution
Yes,
of,
sir, got it.
right? That's why these are independent and that is dependent. So when I say, so if I do this experiment repeatedly for third time, what will happen? Again, the probabilities associated with getting a white ball and a black ball remains the same.
Remains same.
Remains same.
Right? That is what independent, and I can say now the identically distributed also, right? Because these probabilities are getting same. So now the simple case of it. Now this is binomial. So I'll talk about something about binomial. That is what. Let's say I have tossed a fair coin. Fair coin. Let's say 10 times. Okay, and I'm saying that each of the toss or each of the trial is independent, right? Okay, when I say this, what will happen? And
Hello,
then
sir.
define. So yeah,
Hello.
yes,
Hello.
yeah.
Sir,
Tell me.
sorry to disturb you. Sir, I want to ask, can I ask tutorial questions explanation?
Which one?
Tutorial questions explanation.
Okay, fine. We'll do that, but after some time. Okay.
Okay.
Yeah. So
Sorry, but I have another college work. So how long will the session, will the explanation take? So the entire week. Sorry.
week 11.
Yes, sir.
No, I'll try to finish maybe in like 30 to 40 minutes.
Okay, sir. Thank you, sir.
Right? So if I go like, because I'm just not going through like ma'am's way, because it is like it will take 2 or 2.5 hours. We are just going to see what is the meaning of it, and then we'll see some formulas and uh, do the questions after that. Okay, so this explanation will be maybe for next 30 minutes, right?
Yes, sir.
So
That's
let's
a
say,
good approach.
yeah, so let's say this is a binomial variable, binomial random variable, and we define the number of heads or number of heads in 10 tosses. Okay, so this is nothing but what, let's say x1 is the first trial. Okay, what is the outcome of the first trial? Either head or
1
tail,
by
right? No. So I'm just saying that what is the first trial? You can get either head or tail, right? So let's say these are the 10 independent cases or independent random variables. Okay, so suppose in the first random variable, so first case I got head here, right? Here I got head, and what we are denoting here for x1, so we are representing 0 as tail and 1 for head. Okay, fine. So this is for every xi, right? And I will go from 1 to 10. See, it's not difficult to understand, because in simpler way, it's like I have thrown, or I have tossed 10 coins. So let's say, and if I asked you how many heads you have got, so you said 6 heads I have got, right? What does that mean? In any 10 tosses, right? You got
6 head.
So
6
6
heads,
heads,
right?
and that means the remaining 4 you have 14.
Sorry, what did
So
you
you
say?
said there are 6 heads in the 10 tosses.
Yes. See, if I said I have got 6 heads in 10 tosses, what does that mean? I have got 6 heads and 4 tails. But where did you get that 6 heads? In any one of the
10
10 tosses,
trials.
right? Right. So how do you choose those trials? So there may be a lot of combinations, right? So how many times toss coin 10 times, you will get different combinations. Maybe you get 6 heads in first 6 tosses and 4 tails in the remaining 4 tosses, or maybe you get 3 heads in the first 3 tosses, in between 4 tails, and or maybe or how many, okay, 4 tails in between and 3 heads at the end. So you'll get like different combinations, right? So there are, let's say there are these 10 positions, right? 10 position, 1 2 3 4 5 6 7 8 9 and 10. How to choose 6 heads, or maybe 6 positions out of this 10? Because I can have head here, 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 I can have tail here and head here. This is one of the combination, right? Maybe I can have tail here and head here, right? But total is 1, 2, 3, 4, 5, and 6. So how to choose 6 heads out of the 10 toss? So that is 10c6, right?
Yes, sir. 10c6.
6, right? Getting head, what is the probability of getting a head? 1 by 2,
1 by 2.
right?
Right,
What
sir.
is the probability of getting a tail? It's
1
1
by
by
2.
2, right?
1 by 2.
So let's say you are saying that this is the probability, right? So what is the probability that
Can
I
you
will
just
get 6
explain
heads?
what is 10c6 for?
See, I said that you get 6 heads, right? So my random variable is number of heads in 10 tosses. Okay, number of heads in 10 tosses. So I said, what is the probability of getting 6 heads in 10 tosses? Question is, what is the probability that x equals to 6? What does it mean? This is the question. That means 6 heads in 10 tosses, right? So each every time I toss a coin, what is the probability of getting a head for each head? 1 by 2, right? 1 by 2. And what is the probability of getting a tail? It's again 1 by 2.
0.5.
1 by 2, right? Okay. So what is the probability of getting 6 heads? So it is
1 by
1
2
by
to the
2, it's
power
1 by
5.
2, right?
Yeah.
Like that. Yeah. So it's kind of 1 by 2 to the power 6, right? Not
Yes,
plus.
sir.
Actually, it should be 1 by 2 into 1 by 2, right? In, like first, either in the first it's 1 by 2 and 1 by 2 and 1 by 2 and 1 by 2, like this, right? So it's 1 by 2 to the power 6. This is what probability of getting 6 heads. Okay. What is the probability of getting 4 tails now? 1 by 2
Half
to
to
the
the
power
power
4, right? Okay, but
1
this 6,
by 2.
right? So, but where are the 6 heads coming from? Out of the 10 tosses, right? Out of the 10 tosses. So which of these 10 tosses I am getting head? How to find that? From this, right? Right? I can get the 6
So
heads
like out
anywhere.
of the 10 tosses, you're trying to select 6. Sir.
Select 6, right? So this is 10c6, right? So this, I have chosen 6 positions, and the way I can choose 6 positions is 10c6. Then the probabilities associated with the getting 6 heads is 1 by 2 to the power 6, and the for remaining positions, how much it is? 1 by 4. And this is what probability of getting 6 heads, right? This the binomial, uh, binomial or binomial distribution, I can say. And if I wanted to generalize it, I will say x is equals to r, right? And there are, let's say, n number of trials. These are the fixed number of trials. Okay, we know that these trials are there, and I wanted to see our successes. So in this case, our success was getting ahead. Now I'll say our successes. Okay, so what is probability that x equals to r? First of all, I have to choose this r from n, right? NCR.
Sir,
Then
in
let's
the
say, yes, tell me.
so can you say what is n stand?
Number of trials, fixed trials. I have written here, no?
Yes, sir.
Right? So in our previous case, what was number of trials? This 10 tosses.
10.
10.
Right? This was n here, right? 6 is what? R. This is number of successes, right? So probability of getting 6 successes is equals to NCR. I chose, and what is this? Probability of getting
Success, getting heads.
right? So how many heads I want? This R,
6.
6
right?
heads.
And it is 1 minus p to the power n minus r, right?
And minus.
So here you see n was equals to 10, right? R was equals to 6, So this nothing but this 6 is R. Is R. This 4 is 10 minus 6, right? Which is n minus R. So this is a generalized formula for binomial distribution, right?
Excuse me, sir. Good evening, sir.
Yes.
So in this session, are you explaining all of the topics of weeks 11?
11. Yes, yes.
Okay, sir.
So let's find out. Okay, I'll tell you one more question. Simple again. You guys tell me what is it. Okay. Suppose I tossed. Or okay. Suppose I no sorry. I tossed a coin. I tossed and or I tossed a bias coin. Let's say 5 times. Okay. Let x be a random variable. Which which is okay, or let x be a random variable which is defined as getting 3 heads in 5 tosses. Okay, this is my random variable x, which is like getting 3 heads in 5 tosses. Okay, so can you tell me what is n here?
5.
5.
5.
These are the number. Okay,
5,
one thing I didn't define is this is this is a biased coin, right? Biased coin. So if this is
Probability.
a worst case, so let's say probability of getting a head is 0.3 and probability of getting a tail is 0.7. Okay, this is given to you. What is n here? Number of trials is 5. What is r here?
3.
3.
3, right? These are the number of successes, right? You wanted to have. So what is probably on what is asked? X is what? Getting
3
3
heads.
heads. Okay. So I need to find probability that x equals to
3.
x equals to 3. So this, how can you find that one?
5C3 to 0.3 to the power
Right.
3 into
So this
0.7 to the power
5C3 point
3 to the power
3
3,
to the power 3 and 0.7
0.7 to
to
the
the
power
power
2.
0.7 to the power 2.
Right.
Answer is 0.13.
Right.
Then
Okay, answer.
calculation is using calculators. No?
Yes. So yeah, answer. Don't worry about the answers currently. But can you tell me? Okay, this is what it is, and this is correct only. So let's say if x is a binomial random variable, I have defined x is a binomial random variable. What do you think the values x can take? This was a special case, right, where I said x equals to getting 3 heads, right? But let's say x is a binomial random variable, and I defined getting a head as a success. Right? So how many heads I can get?
5.
0.
5
In 5 tries. Okay, in 5 tries, how many?
0, 1, 2, 5.
0,
0 to 5.
0, 1, 2, 3, 4, and
4, 5.
5.
Okay.
So that means I can get either 0 heads or 1 head or 2 heads or 3 heads or 4 heads or 5 heads. Then, okay, if this is a random variable and this is these are the values taken by that random variable, can you tell me what is PMF for this random variable?
Sir, actually
PMF.
one doubt in the question you asked, x must be getting 3 heads or getting heads, sir.
Yeah, no. This was the question where I asked like directly to get what is the probability of getting 3 heads in 5 tosses. Okay. Uh, this is a separate question. This is a different thing, right? This we have found out, that is okay.
Yes.
Now I'm saying that x is a binomial random variable. I just told you that I have tossed a biased coin 5 times. Okay, biased coin with these probabilities. That means probability of getting a head and probability of getting a tail as 0.3 and 0.7 respectively. What I'm asking you is, if x is my binomial random variable, what are the values it can take if head is my success? So I can get 0 heads, right? I can get 1 head, I can get 2 heads, I can get 3 heads, I can get 4 heads, or I can get 5 heads. Now I wanted to find what is the probability mass function for this. So how to find out the PMF, or how to write the probability mass function?
So you have to do P of X is equal to 0.
0, 1, 2, 3, 4, and 5. Okay, maybe I'll just write it like not like this, like this. Let's say x 0, 1, 2, 3, 4, and 5. Okay, right. And I wanted to find probability that x equals to x. What is the small x here?
Getting ahead.
These are the values taken by a random variable, right? This is
Yes.
This is the
values
probability.
taken by a random variable. And which values? This value 0, 1, 2, 3, right? Okay. So when probability that x equals to 0, what is probability that x equals to 0? That means what? Getting 0 heads.
5C 0.3 to the power 0.7.
Yeah, right. 5 is 0, then 0.3 or 0.7 to the power
5.
what about this?
7.
5C
0.3. We get 1 head.
right? This 5C2 0.3 square 0.7 cube. Here it is 5C3 0.3 to the power 3 0.7 to the power 2. Here it is 5C4 0.3 to the power 1 into 0.7 to the power, oh sorry, 0.3 to the power 4 and 0.7 to the power, no, like 1. Yeah. And here it is 5C5 and point.
Sir, this is PMF function for binomial distribution, right?
Yes, this is
Okay.
PMF for binomial, right? Okay, there is an interesting result about this also, but
Sir,
maybe
can you just explain again? Sir?
Which one?
Sir, this one, the PMF 0 for 5C0 0.7 into 2 to the power 5.
Okay, fine. So in the previous experiment, you understand this experiment or this question, you understand how to find x equals to 3.
Yes, sir, I got it. Yes.
So what was that? X equals to 3 means what? Getting 3 heads, right?
Yes.
So we have chosen 3 positions out of the 5, right? That is 5C3.
Yes.
Then what is it? What is this 0.3 to the power 3?
It's the probability of heads.
Probability of getting head, how many times?
3 times.
3 times, right? And this is what? Probability of getting tails, right? And that why this is 2? Because I need only 3 heads, so this is the probability associated with the 3 heads, and remaining 2 tosses I will get what? Tails, and this is the probability associated with that remaining 2 tosses, right? This clear?
Yes.
So if I wanted to ask you, what is the probability of getting x equal to 0? X equals to 0 means getting 0 heads. What is the probability of that? So that means I don't want head in any 5 tosses.
Yes, sir, got it.
So this is
Yes,
5C0,
5C0.
right? That means I have chosen like, so 0 positions, right? And actually you need not to have that 5C0 anyway. This is 1 only. It's like what is the probability of tails, right? 0.7 to the power 5. That means all 5 tosses I will have 7, because this 5C0 is nothing but 1, and 0.3 to the power 0, it's again 1. So this is 1, right? This is what written here.
Yes,
Right?
I got. Sir, I didn't
Similarly,
know that 2 of the questions were connected. I thought it is a different question.
yeah, no, because this is very easily understandable, right? When I ask like specific for one number, this is understandable. We can actually translate it into PMF. That was my intention. So you understand, right?
Yes, I
Okay.
got.
Now I'll ask you guys one more question now, and then we'll finish with binomial random variable. Suppose, let's say I rolled, or I rolled a dice. Maybe I rolled a fair die. Okay, I rolled a fair die, let's say 10 times. Okay, and I said x be a random variable or x be a binomial random variable, uh, with what variable, and okay, one more thing is the out, and I'm defining success to be success as getting a 6 in each row. Okay, so this correct, right? So okay, one of the properties of random binomial random variable is, what is it? Each trial, okay, each trial will have two outcomes. Okay, what does that mean? When I tossed a coin, right, so I had head and tail, that's why this by comes, right, binomial. So by means two, right? So head, if I toss a coin, it is head and tail. Head and tail, that means two outcomes, right? Each of the 10 tosses, I'll get only head and tail, head and tail, head and tail, right? Here also, what is it a binomial problem now? Yeah, because it's a binomial problem because I have defined a success to be getting a 6, right? So I'll get either a 6 or not a 6, right?
So your voice
And
is very low.
is it?
No, sir, it's okay.
No, sir, it's
No,
fine.
sir, it's
That's
okay,
fine,
sir.
sir.
Fine.
Yeah, maybe
Okay,
the
sir.
internet. Okay, so is it okay now?
Yes, sir.
Better.
Okay. Yes, sir.
Fine. So each trial will have two outcomes, right? So what I'm trying to say is, here also we have two outcomes. That is either getting a 6 or not getting a 6. So what is the probability of success here?
1/6.
by
1.6.
6. And what is probability of failure? Maybe, or maybe I'll try
5/6.
5/6.
okay, success and it's a failure, which is 5 by 6.
5/6.
Okay. So if this is a
नहीं
binomial
अब
random
मैंने ऐसे
variable,
अंदाजा बताया
so let's say this is a binomial random variable. What is the range of this? Okay, what is n here?
10 sir
10.
10.
Right? Okay. Now tell me what is the range? Range means
0 to
what is
10.
0 to 10 sir yes sir
0 to n, right? Because I'll get 0 6s, 1 6s, 2 6s,
It says the
3.
number of times the dice is rolled.
Yeah, right. Okay, right. Okay, what will be the PMF of this random variable?
Sir, what is X, sir? Is it getting a 6, sir?
No, it's a binomial random variable, right? Binomial random. Okay, what is X is? Getting certain number of sixes. Number of sixes in 10 rows, right? So number of sixes means, okay, I may get 0 6s, 1 6, 2 6, 3 6, 4 6, like that, right? So that is what, like, we have to define, like, how many number of 6 you want from this 10 rows. Okay, so this binomial will take the range as from 0 to until that number of trials, right? So you can actually generalize this one. What is the range of a binomial random variable is for a fixed number of trials is from 0 to n,
And
right? And accordingly I will define the PMF. So what will be the PMF for this?
it will start with 10C0.
0 1 2 to 10, right? So probability that x equals to x is, so what is this? Probability of x equals to 0 means what?
5 by 6 to
10
the
C0.
power
That is no
10.
6, right? No 6. I can
yes sir
directly say that it should be 10C0, right? Which is again 1.
5/6 to the power 10.
Yeah, 5 by 6 to the power 10. What about this? NC1, or here it's 10C1,
Sir, how
1
it
by
is
6.
10C0, 10C1?
Because see, what is this probability of x equals to 0 means what? Getting
There is no head. Getting no head.
no 6.
No
6,
6,
right?
sorry.
6 in
Yes, 6.
how many trials?
In 10 trials.
10
10
trials.
right? So how to choose 0 trial from the 10 trials? 10 C0.
10C0. Yes,
What
sir.
is the probability of getting a 6 in each trial? 1 by
1 by
6,
6.
right? Not getting a 6
5 by
is
6.
5 by 6.
5 by 6.
5 by
So
6.
0, 6 means 1 by 6 to the power
0, sir.
0,
0.
and 5 by 6 to the power
10.
right? See, I have this
Okay,
10
sir.
10 things, right? So okay, I if I don't want any 6,
In
right, in
case of
10 trials.
binomial in Bernoulli, should we have to use either success or failure only, or can we have multiple?
No, binomial, that's what I'm telling you, right? Binomial means only 2, either success or a failure, each of the trial.
Yes.
Okay, but the success for binomial trial is what? Getting number of like that R, right? The R is a success out of the 10 trials. Okay, R successes in 10 trials, I can say that. Getting R successes in n trials. That is a binomial random variable. Okay, so where was I? So let's say I have 10 tosses. So first toss I don't want a 6. What is the probability? 5 by 6. Second toss I don't want a 6. 5 by 6. 5 by 6, like that. If I do for 10 times, so this the total probability will become 5 by 6 to the power 10, right? That is what x equals to 0, right? And accordingly you can actually find the PMF for this. Okay, this is clear?
Sir, I have a doubt.
Hmm.
Sir, actually in the activity question 11.2 fifth one, I'm not sure how do we classify that as a binomial distribution and what is the value of n and p in that? I'm not able to get.
Question number which
Week
11
11, 11.2. Fifth question.
Okay, just wait.
Sir, can I ask something?
1 minute.
Okay.
Sorry,
you,
sir, it's 11.3.
okay, so are you guys able to see my screen?
No, sir.
No, sir.
No.
Just a minute. There is some 1 minute. Give me 1 minute. Just a minute. Week 11 activity 11.3, right?
Yes, sir, 11.3, question 5.
Question 5. Suppose that 4.5% of people living in a particular city own a Creta. Survey has been conducted to know what brand of cars people use in the city. What is the probability that the 12th person being interviewed during survey is the second one to own a Creta? Okay, this is not a question related to binomial actually, right?
Oh, okay. Yes, sir. That was my doubt because I was not able to find the value of n and p and what was the.
Yeah, because you can see here, you know, right? The probability of success is 4.5. Probability of failure is what? 95.5, right? 0.95, correct? So
Yes, sir.
percentages, if you see, and survey has been conducted to know what brand of cars people use in the city. That is fine. What is the probability that the 12th person being interviewed during the survey is the second one too? So this is not actually, this is what negative binomial. Okay.
How to do this, sir? Like, I also have doubt in the question.
I'll tell you the answer, but I don't think it's there in your syllabus. It was, I think this is a question from the previous one, because 12th person being interviewed during survey.
But how to solve this, sir?
I will tell you how to solve this. It's not a difficult thing actually. It's even if you know the basics, right? It's very easy. Which what I feel, maybe I can tell you with the binomial itself how to solve it. Okay. So can you tell me what is probability of success here?
4.5% of
4.5%.
0.
1 minute. Okay, there is some issue here. 1 minute. Okay, fine. Thank you. So probability of success is, let's say, 4.5% means 0.045, right? Probability of failure, that means not having a creta, is what? 0.95?
955.
955. Okay.
Yes.
Done. So the question is, 12th person interviewed is the second one to own a creta, right? So this is actually a binomial one. If you think it carefully, how to solve it by binomial only. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, right? They said the 12th person here interviewed is the second person to own a creta. What does that mean? The another meaning of it, out of these 11 persons,
One person will be the first person.
yeah, at least not exactly I say exactly one person is
Would be the first one
having a
to.
creta, right? See, if out of this 11 one person is having a creta, that means the 12th one should be the second one to own a creta, right?
Yes, sir.
Right. So consider this, treat this as a binomial problem. Okay, right? You can solve it using the binomial, right? Here n is equals to how much?
11.
11C1, I guess. 11C1.
R is equals to 1, let's say, and P of this is unchanged, right? So how to solve this? 11C1 into
0.045
into
To the power 1.
0.955
To the power
to the
10.
Power 10.
power 10. And I think that should be your answer, because we know that this is 12th person to, who is second one, second one to own a creta. That means we know that this 12th person owns a creta. So it's a sure event, right? It's a sure event. 12th person owning a creta is a sure event. So no probabilities
Probability
associated
of
with
that
this.
will be 1, sir.
So that, yeah, you can multiply with 1.
But
And then
that's
again
not
you can do.
surely written that the 12th person owns the creta. They're asking what is the probability that the 12th person owns the second creta. Like,
No, no,
second
during
person to
the
own a creta.
yeah. So that means he
This is
should be the
correct.
second one. He should be the
Yeah,
second
yes.
one, right? So that means one person previously has to own, right? So let's say you have 2 or 3 persons being having owned the creta. That means he cannot become a second person to own a creta, right? We have to focus on the remaining 11 people, right? Who we have interviewed, and within those 11 people we should have at least one person, or not at least exactly one person, to own a creta, and this should be the probability, right? Correct?
Yes, sir.
And I think
Yes,
that
sir.
is the
Yeah.
answer. That is your answer. Fine.
Yes, sir. Understood.
Okay. What
Sir,
about?
can we do another question of binomials and activity?
Yeah,
Can you
fine.
proceed, sir?
It's 11.4.
Huh.
Question number. One second, sir.
Hello.
Sir, and
Yes.
for this, you have to do it using a calculator, sir.
Yeah, this you can use a calculator, but I don't think exam will have this complex
Yeah.
calculations.
So the first question only, but the question number is 4th and 5th. The situation, the story is the first one.
Okay, consider string of length 4 where each bit can be either 0 or 1. Suppose you want to transmit 4 bits wirelessly wired on a channel. Okay. Okay. This channel is noisy and there is possibility of error. Assume that changing a bit at the ith place is independent from changing the bit at the th place. Assume that changing a bit at the ith place is independent. Okay, fine. The probability of one bit getting changed is given to be 0.1 and let the random array explore the number of bits that changed. Fine. How many bits you are having total?
4.
4,
4.
right? What does that mean? Number of trials are
4.
all of you are agree with this? Right.
Yes, sir.
So n is
Yes.
equals to 4. What is the probability or each of the trial? What is the outcome here? 0 and 1, right?
Yes, sir.
Outcome
Yes,
of
Yes, sir.
trial is
Bernoulli
either 0 and
distribution.
1. So this is Bernoulli one, right? What is the probability associated with 1? It's point.
0.1.
And what about this?
0.9.
0.9.
9. Fine. This is understandable, right? Okay. Now that means what? Let's say x is a random variable. That random variable, it is changing the bit, right? So how many bits can be changed? 0,
1,
1,
2,
0,
3,
1,
4.
2, 3, 4.
So this is typical binomial random variable problem. Okay. What about question number 3? What is the probability that the translated message is wrong? 1 bit error, right? Okay.
Probability of x greater than equal to 1.
First of all, there is a possibility of error. Fine. Assume the changing of bit at the
Just one bit error.
1 bit getting changed is 1. Number of bits that changed. Okay. What is the probability that translated message is wrong? Right. So I think this probability is not related to 0 and 1, right? It is getting changed or not. The bit is getting changed or not. I think that is a probability, right?
Yes, sir. The change is success. Not changing is failure.
Failure. So let's say this success and failure, I'll say, right? So yeah, that means okay. I can actually have lot. I can have 4 changes, 3 changes, 2 changes, and ideally we are actually targeting for what? How many changes?
Error. Um,
So message is wrong when there is at least 1 bit error, right?
What does the question mean?
Okay, I'm 1 minute. Just a
Sir,
Sir,
minute.
can you
error
please?
is defined as not failure of the changing of bits because it's not defined.
Sir, I think the success or failure, you can have it either way. So you can probably have 2 variables and then have it.
I
Because if it
like
is changed, 1 bit is changed to 0.1. So if there are 3 bits, going to be 0.1 to the power 3.
that is true. That is fine. I'm not worried about that. Actually, getting an answer is not a problem here, right? You can actually get the answer, but
The
the
answer
thing
we can
is,
get, sir, but
yeah, understanding the problem is the issue, right? The channel is noisy and there is a possibility of error. So consider string of length where each bit can be either 0 1. Assume that changing a bit at the ith place is independent. That is fine. The probability of one bit getting changed is given to be 0.4. Actually, this one should be written as ONE, right? Like getting one of the bit out of the force. I think that is the meaning of it, I guess. But here, assuming the message is wrong and there is at least 1 bit error.
Yes, given assume the message wrong when there is at least 1 bit error.
Hmm. Okay, now it's kind of like how many errors you can have in the in the 4-bit string. I can have 0 errors, right?
Yes,
0
sir.
errors,
in the success
1
or
error.
failure is dependent on, like, while
So,
transmitting the bits, do we have to change the bits?
no, actually you can see like this. Okay, yeah, changed bit means like error in the bits, right? Changing the bits means error in the bit, right? If it is 0 also, if it is changed to 1, because each of the time you can change the bit, that is an error, right? That will not encode your message properly, correct? right?
Sir,
So the thing,
when we transmit a digital signature or message, so it's like 0 and 1 messaging goes. So what they're saying is, if there is noisy channel, if the channel is not clear, then the message will not go through, and hence
correct,
causing the failure. That causes the error.
correct, that's true. So and in where like we have 4 bits, right? So the
Yes.
bit can be changed at this place, the bit can be changed at this place, this place and this place, right?
X is the
Independent of
number
each
of
other.
bits changed, right?
And wherever the one bit is changed, the message will be erroneous, right?
Yes, sir.
Correct. So how many bits can be changed? Like
Total 4.
0 bits. So yeah, so 0 can be possible, 0 is a possibility, right? 0 bits change means no error, correct? No error in the message, right? Is correct? If
Like denotes the number of bits changed, right?
okay, do you
Will
understand what
that
I'm
change the number of trials?
No, trials will be same. Trials are 4 only.
Okay.
So let's say this is first trial, right? I can have 0 or 1 here. Let's say this is the message, for example. Okay, this is the message. Okay, but due to some error, what happened is, instead of 1 here, I had 0 here. So that means my message has changed now, right? I'll get some different message here, or maybe I can due to error or due to some errors, this 0 has been changed to 1. Still it's a error, right?
Yes, sir.
Still my message is wrong, correct? Right? To get the correct message, the code should be like this, right? The bit should be like this. If this is what I wanted to provide to some other is, for example, I typed 0110 here, you should get 0110 from your end also. If you get something like this, that means my initial, let's say my initial message was like this, I typed 0110 and you get this is your end, right? So let's say you guys get this message. What does that mean? There is an error in the message. This is my message, for example, and this is the message you read, right? Message from your end. Okay, so if any one of this bit has changed, you'll get the error or you get the wrong message, correct? And this message can be changed, and what is the probability of this message to be getting changed? Getting an error is 0.1, right? And probability of not error is how much? It is 0.9, but this is at
No, sir,
every
success is 0.1.
success or
Yeah,
getting an
error is
error?
success.
Success is 0.1 and
Change this
failure
point
is
one, sir.
Yeah, getting the 0.1, if that means what? Getting an error, right? See, your understand? Okay.
Sir, hello, sir. Can you please explain the question once?
That is what I explained it here. Okay. So let's say, okay, it's very simple actually. Now it's
Sir, I
fine.
think like we can easily solve the question, sir, but probably understanding it is.
Okay, fine. Let's say this is my message. My message is like this. Okay, these are 4 bits. This is first bit, this second bit. Okay, let's say this is second bit, this is third bit, and this is fourth bit. So in the first bit, I send a message like this. I wanted to send you guys this message 0 1 0 1, for example, like this. Okay, correct? So what should be output at your end, or what should you see? All of you should see. This is the ideal condition, right? Correct?
Yes, sir. No.
Yeah.
Right. But you are getting like this 0001. Is it a wrong message or correct message? Wrong message.
Wrong.
Okay. You are getting like this. Is it a correct message or wrong message?
wrong.
Wrong.
Wrong message, right? Okay. So anything apart from this combination, right? This is wrong, right? And how will you get wrong messages? If any one of the bit here, right, is getting changed, right? So any one or more, right? So for example, if you I wanted to send you 0101, instead of that you got like this. what happens? How many bits here changed? 2 bits changed, right? Still this is a wrong message, right? Correct?
Yes, sir.
Or this happened. How many bits are changed now here?
2.
4.
4, yes, sir.
Right? So still it's a wrong message, correct?
Yes, sir.
So if you like either 1 bit is changed, still you'll get the wrong message, right? 2 bits are changed, you'll get a wrong message. 3 bits are changed, you'll get a wrong message. 4 bits are changed, you'll get a wrong message. Only when 0 bits are changed, you'll get a correct message, right? That's
okay,
fine.
sir.
Fine. But each of this bit will be changed. What is with what probability?
0.5.
0.1, right? 1.
Yes, sir.
And 0.9 for
9.
is for
Not changing.
not changing. This for changing. Right. Okay. Now, what is the probability of getting x equal to 0? 0 x equal to 0 means what?
Nothing will change.
No bit has changed, right? So what is the probability? 4c 0.
Is it all the 4 bits are 0, 1, 0, 1?
Yes, that is mentioned there, yeah? In the first line, where each bit can be either 0 or 1, right?
Yes.
Fine. So 4c 0. What is it?
0.1 to the power 0.
0.1 to the power 0, 0.9 to the power 4.
Right. This is
Yes,
what
sir.
correct message.
Yes.
What about probability of x equals to 1?
4C1
0.1.
0.1 to the power 1 and 0.9 to the power 3.
This is what wrong message, right? So right, so I can have like wrong messages when at what situations? When 2 3 4 1, right? So if I wanted to have a correct message, this is the probability, right?
Yes, sir.
And what is the probability of getting a wrong message? That is x equals to 1 or
Greater
probability of
than
x equals
equals to 1. Yeah.
to, right? That's right. In other way or alternative way, what is it? I can write this as 1 minus probability of x
X
equals
is
to
equal to 0.
0. Is correct? Because the
Yes, sir.
probability of x equals to 0, this should be equal to 1, right? And
Properties
this
of
what?
PMF.
Yeah, and this is what? This probability of getting a
Error.
Wrong.
Wrong
wrong
message.
message. Wrong message. Right. This 1 minus 4c0, or I can say directly 0.9 to the power. Done?
Yes.
Yes,
Thank you
sir.
so much, sir.
Sir,
Fine.
question 8 from 11.5.
Just a minute. I'll come back in 2 minutes. Okay.
Okay.
Sir, I want to ask week 6 tutorials explanation. Some tutorials explanation.
Sir is not here.
Okay, tell me which is the question?
Hello.
Question 8 from 11.5, sir.
I want to ask tutorial questions of
expectation variance, right?
explanation of week 6.
11.5, question 8.
Yeah. But 11.5 is dependent on what expectation and variance of a random variable, right?
Yeah.
I'll just binomial random. I'll just
Hello.
Okay, can we
Yes.
just finish the concepts and then take the
Can
doubts?
we ask
Yes,
week
sir.
6
Can you just finish
tutorial
the
questions?
concept, sir?
No, see, week 6 and all we'll discuss it later if we get the time. Currently, we'll talk about week 11 first, right?
At the last
If I
of the
get
Sir,
class.
Poisson's one.
At the
Sir,
last of the
actually,
class,
for
can
doubt
we ask?
sessions, there are
one
TA
minute,
sessions in the
See,
morning.
talk, speak one by one. So don't, it's like if you tell me the name and then you speak. Yeah.
Sir, my name is Suryas, and I
Yeah.
want to ask that in the last class, in the last time of the class week, can we ask this week 6 time?
Yeah. At the end, I will take some questions from week 6 if we get the time. Okay.
Okay.
So I actually I estimated that you guys have completed everything, so that's why I started with concepts, but I have to finish it before. Fine. Okay. Anyone who wants to speak now?
Sir, you can you now discuss Poisson's?
Poisson, I'm going to discuss this definitely. Poisson and this one.
And sir, for
Hypergeometric.
doubts, there are two sessions by TA. They take.
No, it's okay. I'll take the doubts
So
also.
actually, it is so because there are separate. If could you just clear the concept first, sir? Like, all
Yeah,
about
I'm doing it.
Yes,
Yes.
sir. First concepts.
Yeah. So binomial
This
random variable.
session would be recorded. This would be recorded, sir.
Yeah. This is recorded. You'll get the YouTube link,
Okay,
right?
thank you.
Okay. So with respect to binomial, I'm not going into detail of what is expectation of x. So suppose x is a binomial random variable. Then what is the expectation of x here? N into p, right? What is n?
Number of trials.
Sorry, number of tries, right?
And P probability.
And actually, we'll denote it like this: n into p, two parameters. And this is what?
Sir, what is this called? That x and this sign and binomial n comma p.
Probability of success.
What is this? This one? This is like this is a sign is kind of like this is a random variable. For example, x is a random variable which is which is distributed according to the binomial distribution and with these two parameters n into p. And what is n? Number of trials, and p is the probability of success in each trial. Okay. Okay. So expectation of x is what? Nothing but n into p. You can get the derivation from the lectures, and it's not easy actually to derive because what is in general what is the expectation of x? It's summation of
x dot px.
What is this? X is values.
Random variable.
No, values taken
Expectation
by
of
random.
x square minus expectation of x to the whole square.
Oh, that is variance. So, okay, you guys have you guys have finished the random variable, right?
Yes, sir. Yes, sir.
Yes, sir.
Why this issues? Okay, so general definition of expectation of x is what? Summation of x into probability that x equals to small x. Okay, this is the definition.
Yeah.
What is x here? X is
values of random variable.
Values taken by random variable. Okay.
And this is also called
and
long run average.
Yeah. So yeah, that is the meaning of that is the physical significance of expectation of x, right? Okay. What in this case, in the previous case, when I tossed a coin, or maybe yeah, here this was the range, right? X equals to 1 to 10, right? So you guys have for finding the expectation, x will take which values? 0, 1, 2, 3, 4, and we have to sum it until x equals to 10. Okay. over the range of the random variable capital X, you have to sum it. So what is the range of binomial random variable here?
0 to 10.
No, in this case, in the generalized case.
0 to n.
0 to
0
n.
to n, right? Okay, fine. So I have to sum it from x equals to 0 to n, right? And is x into what is probability of x equals to x? Or I'll say, let's say, yeah, that is fine. X is fine. X. What is probability of x equals to x? nc x p to the power x and 1 minus p to the power, right? So okay, fine. And if you do the calculations,
So which topic is this?
expectation of a binomial random variable. Okay,
So is this derivation is important?
important, it's not important. You can actually, that's what I don't want to go into the derivation. It's already been there in the lectures. So I'm just trying to tell you is expectation of a binomial random variable is given by n into p. What is variance of binomial random
N
variable?
into p
N
of
into
minus
P
p.
into 1 minus P.
Okay, what is n here? Number of trials.
Number of trials.
P
And
is
p probability of success
probability of success
in each trial.
Yeah, in each trial, that is important. And 1 minus p is, yeah, it's a probability of failure. Okay, now we'll come to the
Failure.
question in 11.5, question number 8, right?
8.
Okay, what is standard deviation?
The square root of
Square root
variance.
of variance.
Square root of variance. Okay, are you able to find the answer for question number 7?
I have tried this way, but couldn't get the answer.
Yeah, that is fine. But what is, did you get the answer for question number 7?
Yeah, it was second, B.
So how do you find out that?
I have derived it because 6 out of 15, 6 are red and 9 are different.
Okay, so suppose an urn contains marble of 2 different colors, red and yellow. A marble is
Which
drawn from
assignment is this?
activity questions 11 point, I think 5, question number 8. Okay, so suppose an urn contains marble of 2 different colors, red and yellow. A marble is drawn randomly from the urn and its color has been recorded. Okay, then the marble is kept in the urn. And what do you mean by that, keeping an urn and remixing? It's a replacement problem, right? With replacement. So that, and what happens when we do replacement? The probability of the success or in each trial will not
It is
change, right?
independent and identical.
Probability
Yeah,
remains
right?
same.
Okay, so probabilities remain same across the trials, right? That we have seen earlier. So suppose the proportion of yellow and red marble in the urn is pi 1 and pi 2. Let the urn has 15 marbles, out of which 6 are red, and a total of 10 marbles is drawn from the urn. Okay, so I think that pi 1 and pi 2 is proportion, right? It's very easy to understand. So if there are 15 marbles, right? Urn has 15 marbles, okay, and among which 6 are red.
Plus 6 by
That
15
means
6 by 15
yellow,
and 9 by 15.
yeah, yellow is what?
Yellow is
9.
Yeah, 9 is 0.6.
Okay, I think that is okay. If you understand this proportion, I think then there is no problem. See, I think we have started with the same problem, right? Only the 3 blue balls and 2 red balls. I think black balls or white balls I have taken, right? So currently here, how many? 6 red
6
balls?
and 9.
9 are
yellow.
Yellow balls. Okay, and I have taken out 10 random balls, but with replacement, right?
Yeah.
With replacement. That means this is the problem of binomial random variable, right?
Right.
So what is the probability of getting a red ball in each trial? It is
0.6.
6 by 15. Not
Yeah, 6 by
0.6,
15.
right?
6 by
And probability of getting a yellow ball is
9 by 15.
And this is correct across each trial, right? or this
Yeah.
is same across each trial. Okay, so this is kind of getting a head and getting a tail. Now this is a outcome of your trial. So we have chosen how many balls now? 10 balls. What does that mean? I have done this
R is
experiment how
10.
many times? 10 times.
10.
N is 10.
N is 10 here, right?
Yeah.
N is 10. Probability of getting red is 6 by 15. Probability of getting yellow is 9 by 15. Fine. This is understandable. Okay.
Yeah.
Now the question is, in the experiment, find the standard deviation of number of yellow balls drawn. So here, what we are seeking here, success is what?
Yellow ball
Number
is
of
drawn.
yellow balls drawn.
Yellow
Yellow
ball
ball.
drawn. Yellow ball drawn, right? Okay. So I don't know how many yellow balls can be drawn.
0 to 9.
0 to 9, right? So that is the range, right?
Yes, sir.
Not, yeah, 0, 1,
0 to
1,
9
2.
it should be. Because we have total 9 balls, yellow.
No, I don't. Oh, sorry. This is not 0 to 9. This should be 0 to 10, right? Okay, but I don't. Okay, we can't go to 10 because we have
9 only.
only 9 yellow balls. Fine. This is the range. Fine. So now, if this is the range, what is the problem here now? Finding out the variance.
They're finding their probability of x is equal to 0, 1, 2, 3, 4.
Okay, how to find the variance now?
So we just use the formula NP into 1 minus P.
But what is n here now?
N is 10.
10
P
and
is 9 by
9 by
15.
15.
But after finding the probability, we have to find the standard
That is
deviation.
the issue.
It was lots of factors.
What should be N?
By using the formula of variance NP into 1 minus P.
But will that be correct answer? Okay, just try it. Just check if the answer is correct or not. Because I feel this should not be the correct answer. I can calculate the answer. What is it?
Coming 1.04.
Okay, I understand. So this should not be like this.
So I think we have to find the variance and then do the square root.
Yeah, that I understand. That is not a problem. Okay,
So
so
it is
actually the answer is coming from here only with this n into
with
p.
replacement only, sir. So x
Yeah.
is equal to 0 to 10.
No, but 10 is not. Okay, fine. X is what?
So I
X is
got
what?
1.54.
0 yellow balls, 1 yellow ball. But I cannot have 10 yellow balls, right? I cannot
So
have 10
with
yellow balls.
replacements.
With replacement,
What
also,
will P be?
how can I have the 10 balls if I have only 9 balls?
Oh, okay, understood.
That is a problem I'm having. Okay, so okay, the answer actually coming as n into p into 1 minus p, with n being 10, 6 by 15, and this is 9 by 15, right? But I'm not sure about this answer. I'll check the answer and let you know, right? The problem here is the range of x is not from 0 to 10, it's from 0 to 9. Understand?
Okay.
You understand my point? So this question cannot go like this, which I feel, right? Okay, I'll maybe the next session some the instructor whoever will be there, they will maybe if I am there, I'll tell you the answer. You understand the problem, right?
Yeah.
Because I am having only 9 yellow
9.
balls,
Yeah.
I cannot have the range of x to be 10. right? And if this is not 10, then I cannot find the variance of x with this formula,
Yeah.
right? Because anyway this formula is coming, it comes when x is of that range, right? Of range of n, right? Because expectation of x, how we have found out? From x equals to 0 to n. But here this n is not n, it's n minus 1 actually. So I need to recheck this one. Okay, I'll check the answer later on and I'll let you know. Fine.
Okay.
We'll move ahead maybe. Okay, now I think the hypergeometric, right? Or should I start with Poisson first and then
Hypergeometric, sir. Let's go in sequence.
Okay, hypergeometric is fine because we are already at fine. Okay, so I'm not going into too much of details here. Then hypergeometric is what? Let's say you have total of n number of objects. Okay, and this is similar to what we have seen initially, right? 3 red ball or maybe 3 black balls and 2 white balls. What we have seen is if I have chosen 2 balls without replacement, what will happen? The probabilities across each trial will not be
Same. Not
same,
same.
right?
Yes,
Right?
sir.
Yeah.
And this hypergeometric will come into picture when this without replacement. So let's say there are total of n objects are there, and if I choose some total of n objects out of which there are, let's say, some m are of one kind, then n minus m of r of another kind. What does that mean? I'll tell you. So suppose how many total balls are here? 5, right?
5.
So this I'll denote it by capital N. N is equals to 5. How many balls I have randomly chosen?
2.
2, right? Okay. Let's say I wanted to find my success as, or what I wanted to find the probability that exactly one ball is white. Fine, right? So here it is. Let's say one is m. Then the remaining n minus 1 m will be 2 minus 1, which is equals to 1, right? This is the scenario. Actual scenario is like this. So probably I'll take some other example here. Suppose I have 10 black balls and let's say 5 white balls. So total number of balls are, how many balls are there? Total number of
15.
15. Small n is, let's say I have chosen again 5 balls randomly. Okay, and I wanted to find let's say 2 balls are white, so 2 are white and n minus m means how many? 3 are black, right? So what is probability that 2 white balls are there? This is a hypergeometric problem. So how to find this probability?
So what
So
is this M? How should we define what is M?
M is okay. There are actually 2 categories here, right? One is blue ball, one is black ball, and another one is white ball, right?
White ball.
Okay, and this M actually comes from the question itself. Like, for example, if I wanted to, my success is number of white balls, and
Okay.
here let's say there are 2 white balls. I wanted 2 white balls, so
Okay,
M
sir.
will be 2, and the remaining balls will be 3 black balls. 2. So what is probability that there are exactly 2 white balls are there?
Okay, sir.
Okay,
Thank
what
you.
is in
Then we're
generally how?
choosing 5 balls.
Yeah. Okay. Fine. Uh, okay. Basic probability definition is what? Favorable outcome divided by total outcome, right?
Yes, sir.
This is my probability definition.
Yes, sir.
Okay. Okay. What is total outcomes here? So what is it? Like I'm choosing 5 balls, right? Randomly. So how many ways are there to choose 5 balls out of the 15 balls?
15 C5.
15 C5. And that should be my what? Denominator.
Total.
Denominator.
Right, total, because these are the total number of ways in which I can choose 5
balls from 15 balls.
Yeah, 15. Okay. Okay. Favorable outcome is what? 2 white balls, right? So 2 white balls is what? What is the probability?
2C2.
So like out of, sir, can you just explain n is equal to 5 and 2 white and 3 black?
So I need 2 white balls here and 3 black balls. But getting 2 white balls is from where? Out of 5 white balls, right?
5. Yes, sir. Okay.
5C2.
5C2. Probability of getting white balls, 2 white balls.
Okay. 5C. Right. 5C2 is what? Actually,
selecting
out of these 5 balls, first of all, out of these 5 balls, I wanted 2 white balls, right?
Yes,
So
sir.
out of 5, I'll choose 2 actually, 2 positions, kind of like that, right? And what is the probability of getting white balls here?
Is 2/5.
Okay, so let's first
5/15.
maybe I'll take one example from here itself, from ma'am's lecture. I'll just take one. Okay, I'll check whether first of all I have 7 balls of white and 3 are black. Okay, a student random samples 2 balls. Okay, probably I have defined M wrongly, I guess here. Right? Fine. Right. Okay, fine. So the mistake I had done here is this one. And this M. Okay, what is M here actually? Sorry. So M here is what? Number of white balls. Okay. And what is N minus M here? Number of black balls.
Black balls.
Okay. Now I think now we are clear, right? So I wanted to find the probability of getting exactly 2 white balls. In that case, what is the probability of getting white balls? There are total of 5 white balls here, right? Correct? 5C2 into.
And the ways of choosing blue ball is 10C3.
10C3. That should be the probability of getting 2 white balls. Understand?
Yes, sir.
So this is the problem. Okay, maybe I'll take one problem here from here itself. So okay, so this is actually this is PMF of the PMF for the hypergeometric random variable. I will come to that PMF first of all. Okay, all the examples of all only. Right? So I'll write it down again freshly. So suppose the question was like this, right? There are black balls and there are white balls.
Can you just show the slide again?
1 minute. You can understand from here itself. Okay. 10 black balls, and you have the slides anyway with you, right?
Yes, sir.
Yeah. So you can check it from there. So just here I wanted to tell you is like this. Suppose so how many total n is how much? 15, right?
15.
10 plus 5 is 15. Okay. I have chosen 2 balls randomly. Not 2 balls, 5 balls randomly out of this 15 balls randomly without replacement. This is the condition for hypergeometric random variables. Okay. Now I want it. Okay. And my success is, let's say, success is just chosen, let's say 4 balls randomly. Success is getting white balls. Okay. Now, can you tell me if x is a hypergeometric random variable, what will be the range of the random variable?
So how do we identify an hypergeometric?
0, 1, 2, 3, 4.
Yes. So total n is how much? 15, right? Small n is what? 4. The 4 balls we have chosen, right? And my success is, let's say, getting white balls. So how many white balls I can get?
5,
0. I can
0
get
to
0,
4.
1, 2,
2,
3,
3, 4,
4.
5.
4 only, not 5, because
Why,
I have
sir?
just I have selected 4 random
Most
balls
of
only,
the
right? Or
Okay,
4.
sir.
I have chosen only 4 balls out of this 15 balls.
So how
So
do
in
we
that
know this is the
case,
hypergeometric distribution?
yeah, okay. How to understand if this is a hypergeometric distribution is what? You will have, you will have 2 categories first. Okay, 2 categories, and which are the 2 categories are here? Black balls and white balls, right? Right. In this case, it is black balls and white balls,
Yes.
and and you can actually tell, like, denote them as, let's say, m of one kind, m of one kind. So m is what denoting here? 10, right? If this is a black ball, or if this is a white ball, then m is what? Suppose, okay, let's say this is white ball. We have 2 categories. One is white, another is black. And let's say I'm denoting this as m, and this as capital N minus m. Okay, capital N minus m. So m is how much? These are numbers.
5.
So m here is
And is it the total
5.
number of balls minus m, or is
N is total number, right? This is what given here. See, don't confuse with this m and n minus m. Okay, first of all, understand that how to identify this is a hypergeometric problem is, first condition is there will be always 2 categories. Fine, and that is you can resemble, you have resemblance with what? Binomial also. Binomial also will have 2 categories every time, right? But here also we'll have 2 categories. But another important thing is, uh, this will be coming with without replacement. That means each time the probabilities will change, each of the trial. Okay.
Dependent probability.
Yeah, dependent probabilities. And another thing is, the probabilities will also change for like after every trial, and we can easily find it out here. So here you can, and now you are choosing how many balls? N, right? N. So getting 0 white balls is what? 0 white, 1 white, 2 white, 3 white, and 4 white. I cannot go for 5. Why? Because I have chosen only
plus
4
who's
balls
available?
here, and this is small n actually. Okay, maybe we'll take one example from your activity questions, and maybe we can able to understand it properly. Okay. First of all, tell me what is the probability of getting 0 white balls here? What is the total outcome here? Total number of ways to choose n balls?
15C.
15C, 4,
4.
right? What is the like, in how many ways I can select 0 white balls? 5C, 0, right? Into, so remaining 4 balls will be from coming
Sir,
from
it's
when?
4C0 or 5C0?
5C0. This MC0, right? MC, actually this
Yes, sir.
cortex.
Yes, I got it.
Understand, right? Right. This is what? This is not probability. This is
White ball.
number of ways in which we can select white balls. Right. Okay. And now, what is the like, in how many ways I can select
11C4.
4? Yeah. Okay, 11.
NC4.
Not 11. Not 11. 10. 10C4. Okay. So you
Sir,
understand now.
how 10, sir? 15 minus
Not 15 minus,
5.
like,
Yes, sir. Yes, sir.
understand, right?
M
We have only
minus
10. See, we have only 10 black balls among. So if you have 0 white balls, that means these 4 balls will be coming from where? Black balls only, right?
Yeah.
And in how many ways I can select those 4 balls from the black balls? It's in C4. So if I generalize this will look like this: M, C, yeah, I can say X or R. Let's say R.
R, sir, R.
Let's say I say X, for example. Okay,
Either you
because
can say MCI, sir.
MC X. X is what? Each value taken by this random variable, right?
Yes, sir. 0, 1, 2, 3, 4.
And you can think of it as R also, it's not a problem, but you should understand what is R here. So I'm taking the small x because generally what we do is these x are from range, right? It is coming from the range of that random variable. Okay. And here it is capital N minus small m C. What is here?
N minus X.
But this n is small x, and it is what? Number of balls chosen, right? Here 4, and divided by what?
N choose N.
N choose N. Understand this problem? Understand
Yes,
how to
sir.
find the probability?
Yes, sir.
Yeah.
Excuse me, sir.
Yeah.
Sir, we just had one doubt, sir. Like here, we identify the question on the basis of if there is replacement or if there is not replacement there in
Yes.
the in choosing. So I just wanted to know, sir, like why do we use combinations, sir? Can we why don't we use permutation? Like in the previous permutation combination, sir, ma'am, you should teach that if there is replacement possible, then we use combination in arranging, and if it's not, then we use permutation, na, sir. So I just wanted to know if there is some
Sorry.
connection.
Go slowly. Go slowly. I don't understand what. Okay, you. Until now, I understood. Like from where you started that permutation combination. Can you just tell me slowly?
Yes, sir.
What is
Like
it
in
of?
combination, sir, ma'am taught that if like there is replacement is not possible, we use permutation in arrangement, sir. So like why don't we use here permutation and why don't we use combination instead of
Okay.
permutation?
Okay. Fine. So what is permutation in general? In general, it's an arrangement, right?
Yes, sir.
Right. And what is combination? It's a selection.
Okay, sir. Yes, sir. Yes, sir.
Correct. That is understandable, right? You understand that thing at least, right?
Yes, sir. Understood, sir.
Permutation is a selection, and arrangement is a sorry, permutation is an arrangement, and combination is a selection. So when you are selecting something, you will use combination, right? When you wanted to arrange something, then you will use permutation. But that permutation is
Yes.
what, let's say you wanted to arrange 4 people on 5 seats, or let's say you have 5 people, like, okay, and you have only 4 seats available. What you will do, you will select 4 people first, and then you will arrange them on the 4 chairs, right?
Yes, sir.
So,
Yes, sir.
so the permutation is nothing but selection and then arrangement. So it's generally arrangement. Okay, and when you are going to select something, you have to use combination. And what we are doing here, we are selecting 4 balls.
Yes.
And then definitely we have to use what? Combination only. It does not depend on what replacement and without replacement. Okay. Fine.
Okay, sir.
Okay. So
Yes,
maybe
sir.
we'll take one example from activity question, so that we'll be able to understand what is exactly it is. So let's say activity question. Okay. Sorry.
So can you also explain expectation and variance of this hypergeometric distribution?
I will do.
Sir, I am confusing in variance, sir, of hypergeometric.
Okay, I will tell you. It's not very difficult, you know. So that is the only formula I think you guys have to remember anyway. Otherwise, it's not much difficult here. Okay, we'll talk about that also. No issues in that. Just for 11.6. Uh, okay, now suppose that 5 fruits are randomly chosen from basket containing 20 fruits, of which 16 are good and 4 are rotten. Let y denote the number of rotten fruits chosen. Okay, so what is capital N here?
5.
Capital N.
Capital N is 20.
20, sir.
20.
20, sir.
Total number of
20.
fruits is 20. Okay. What is
A
what
small
is
n is 5.
no small n is actually you can take it from here itself, I guess. Yeah, sorry. Small n is what? 5, right? Correct.
Yes, sir.
Yes,
So
sir.
Yes, sir.
and y is what? Denoting the number of rotten fruits chosen.
4.
M is 4.
M
Miss
is
4.
4,
4.
sir.
N minus m is
16.
16, right? Okay. And let y denote the number of rotten fruits chosen. So what will be the range of y? So it can be
0,
0
1,
rotten,
2, 3, 4.
0 to 4.
4 only,
Yes,
right?
sir.
No 5, right?
Yes, sir.
No.
Yes, sir.
Even though we are choosing 5 fruits, so I'll write down the question here, and maybe I'll write down all the, sorry. Okay, and I left my pen somewhere else. Okay, hold on. So there are total of 20 fruits, among which 16 are good and 4 are rotten. So since I'm interested in rotten fruits, I'm denoting this as M, and then this will become N minus small m. I have chosen 5 fruits randomly, and this will denote small n. Okay, and y is the random variable which says the number of rotten fruits where in the n in the 5 chosen fruits, right? And this is chosen. Fine. This is okay. Now, can you tell me what is the range of y? So y can actually, so y is based on n, but y is also based on small m, right? So the range of I can have 0 rotten fruits in the 5 chosen fruits, or I can have 1, I can have 2, I can have 3, or I can have 4. Okay. Done. What is the probability that y equals to 2? What does that mean, y equals to 2?
2 rotten fruits, sir.
2 rotten fruits where
And 3 are good.
in 5 chosen fruits, right? Is okay. Fine. So what are the number of ways in selecting 5 fruits out of the 20 fruits? 20C
20C5.
5. And here what will be there? Like I'm interested in 2 rotten fruits. So 2 rotten fruits will be coming from where? This 4, right?
4C2.
4C.
4C2. And the remaining, how many remaining fruits will be there? 3.
16C.
N minus R, right? Or N minus X. N minus X, which is 5 minus 2, which is 3, right? So here it is 16C3. So you can see this is small m, this is small y in this case, right? 16 is what? Capital N minus small m. This is small n minus small m. Done? Sorry,
Yes, sir.
this is wrong. This is wrong. This is this is correct only, right? Yeah, this is correct.
n minus sir y होगा यहाँ पे.
N minus y.
Yes, sir.
Yeah, N minus y. Done. Correct, right?
Yes, sir. Correct.
Okay, done. Yeah, fine. And this is what? This is capital N. Choose
N.
small n.
A small n.
Done. That's fine. This is your hypergeometric random variable, and I think the expectation of it is what?
Nm upon n. Small n into m upon n.
Small n
Into m.
small m upon n. What is it? N is what? Number of fruits chosen, right? Number of or objects chosen. M, small m is what? the
Number of
success rate,
chosen fruit
number.
is
The
present.
successful or whatever is required.
Yeah, whatever is required, and that is total. So you can actually okay, fine. This is the formula, and how you have derived that you can see from the lectures maybe. But
This
what
formula for expectation of x is only for hypergeometric distribution.
it is there? It is for that hypergeometry only. 1 minute, I just need to check slides whether I'm correct or not. I need to check. 6, 5. Done. Right. Okay. Here it is fine. Okay, we have done with this. So I'm going to see this.
This n into m by n is only for hypergeometric distribution.
Only for hypergeometry. There is so this is like very
Derivation
very.
is confusing.
It's not confusing, I guess. It's not that difficult, right? Do you want me to solve or?
No, sir.
Okay, a lot of people are having the
Explain
problem.
variance.
Variance, like this is a formula only, right? Okay, you wanted me to solve that derivation for variance. You're saying?
No, sir.
Okay.
So we'll go through it, and then if you have any doubts, we'll ask.
Yeah, actually, see, the thing is, this will come from the derivation only, this formula. But how to remember this formula is there is one, like, see, this n m upon capital N is I think this resembles to your mean, right?
But
Expectation
the
of
questions on variance is quite low.
yeah, because we don't ask questions, because this for remembering this formula is a tough task actually, right? That's why we
Yes,
don't
sir.
ask questions in the problem in the question paper, right? This is the formula, actually it's there. If you want derivation for this, maybe you can check online, or see, it's deriving, it's not that easy, right? But you can use the method, like simple method again, is what how to define variance of any random variable. It is
E of
expectation
x
of,
square minus E of x to the whole square.
right? Yeah, we know that E of x is what, n capital M upon, oh sorry, small
Nm
n,
upon n.
yeah, and this square you have to derive it for this, but this is again not simple. Again you have to derive it like this, right? X square into what is this,
Sir, for the
n.
expectation, the division of n, the capital N is only for this hypergeometry.
Sorry, sorry, what you said?
Sir, this nm by n, the formula for expectation is
Ah,
only for this hypergeometry.
yes, not for
The
others.
others were, yeah, the others were different.
Yeah, so for binomial, what is it? N into p, right?
Np.
For hypergeometry, sorry, for Poisson, it is expectation is, I think it
So
is
please explain
lambda.
Poisson distribution.
Yeah, I will explain. So yeah, I'm having, like, maybe I can take the class only for next 15 minutes. Okay, so whatever is there, if anything is remaining, we'll discuss it in the later class. Okay. So yeah, I have some foundation today. Otherwise, I would have taken the class a little longer. So yeah, this is I'm actually
So the binomial is formula for variance.
sorry. What is the formula for variance of the
Variance in
binomial?
binomial distribution.
This, like, can I summarize all the formulas here directly? Will that be okay? Okay. So expectation of x is, in case of binomial, it is n into p. Variance is n p into 1 minus p.
1
Right.
minus p.
Right. I'll explain for Poisson also. Poisson expectation is
Lambda and lambda.
lambda, and variance is also lambda.
So what
Right?
is lambda in the Poisson distribution?
That I'll tell you this one. So first of all, I'll finish this one. So okay, how to find the summation as this x square? What is mcx? You can, if you want to derive, you can derive it later on. Like m factorial upon uh, what is it? X factorial m minus x factorial, right? similarly you use the factorial notations for here, and then you can derive it. If you want some derivation, we'll post it on the discourse, right? But you can directly mug up that formula. That is fine. That is only fine. And generally we don't ask questions on the variance of hypergeometric distribution. You should remember uh, expectation of a binomial random variable, variance of binomial random variable, expectation of hypergeometric, and expectation and variance of Poisson random variable. Okay, fine. So what is Poisson random variable? What is Poisson random variable? The what is the events that occur in the fixed interval of time or space, right? This is the definition of Poisson random variable. That
Sir, can you explain the space with
yeah,
example?
space and yes, we have the. So if you have gone through the lectures, you may see like several examples given by ma'am. So I'll just take those examples only. Okay, at the end it is there, I guess.
So this is the last topic for week 11.
Yes, yes, yes.
Some words was for example.
Can you explain
11.8
Poisson
lecture.
and detail Poisson distribution?
Yeah, we'll go. It's don't worry. A Poisson distribution, actually you need not to derive anything or understand a lot of things. It's like it's a derivation. It's okay. Maybe you can derive it from or you with the understanding itself you will understand that. So first of all, what are the events occurring in fixed interval of time? So number of vehicles passing through a traffic intersection in a fixed interval time of 1 minute. For example, if you are at at one any red light, right? And you see when at the signal, if it turns red, the signal it turns red, and you'll count the number of vehicles going through that signal in 1 minute of time. That is what that will follow what Poisson distribution. So generally the number of people withdrawing money from bank in the time interval of 15 minutes, number of telephone calls received per minute at a call center, all these are the examples of Poisson distribution. What does that mean? The you should have discrete number of or you can have you should have the discrete variable in the and or you can say the events should be happening in the fixed interval of time, and these events should be discrete. So number of vehicles here is what? A discrete random variable, right? And what is the fixed interval of time here? 1 minute. So in 1 minute, how many number of vehicles are passing through that area, right? That is what Poisson distribution, right? That is the Poisson distribution, and this is what with respect to or with the fixed interval of time, right? When you say fixed interval of space, that means see, this is another example, number of typos in a book. So you have one book, let's say, and in that book you are saying that there are 10 number of mistakes are there. Okay, these 10 mistakes are there in the let's say 500 pages of the book. So this is a space, right? It's 500 pages of the book. It's a space in that 500 pages, or you can say there are like in that 500 pages also you have say a number of like finite number of words are there. So let's say in each page we have 10 words, right? So in 5,000 words, how many mistakes you have found? 10 mistakes you have found, right? So occurrence of these 10 mistakes in that book, uh, it follows Poisson distribution. A number of defects in a wire cable of finite length, number of defects in per meter in roll of cloth. So these are with respect to space, right? This cloth, the wire cable, the length of the wire cable or book. These are what examples of space. So you define some space, and with respect to that space, you are counting something, right? With so you say like number of typos in a book is let's say 10, but each occurrence of each error is having some probability, and how to define that probability is what? By using the Poisson distribution. And what is
Hello.
the yes?
Can you week 6 down?
Sorry.
Week 6 tutorial questions explained.
Okay, week 6. Maybe can we discuss it later on? Because okay, I'll tell you the problem is I cannot extend it too much because I have to go outside for having food. Right?
Then can you explain some other days because it's likely.
Sorry.
Please just one question.
I'm not able to hear you clearly. Can you speak loudly?
Please explain just only one question.
One question from week 6 you wanted?
Yes.
Okay, fine. Then you can tell me right now.
So will you explain the Poisson distribution in the next class?
Okay, fine. I'll do it again, maybe. Okay, that's fine.
Yes, sir. In the next class,
Yes,
please
sir.
explain this in detail. The
Sir, when
Poisson
is next
distribution.
class?
Sure. I'm not sure like whether what is showing in your calendar. Statistics. Okay, maybe Saturday or something, right? Or maybe in between we'll fix one class, and in that class we'll show this one. Okay, can you tell me that question? Week 6.
Week 6 tutorial 5. Tutorial 4, sorry.
Tutorial. You wanted to have.
Can I leave this session?
Yeah. Yes. Fine. Yeah. So week 11, maybe we'll continue that Poisson distribution will continue in some other class, right?
Excuse me, sir.
Yeah.
Sir,
Okay,
can
sir.
you just put some lectures like the revision sessions after the portions after quiz 1, the week 5 to week 8 or week 9, because we have some doubts in permutation combination and some conditional probability and Bayes theorem in that weeks.
Fine. Maybe next week
Yes,
we can
sir.
have. Okay, next week we can have one revision session. Okay.
Sir, I have one doubt.
My screen is not visible. Okay, fine. 1 minute. I'll finish this tutorial first, and let's see. Which the doubt in which topic?
General doubt.
General doubt. Yeah. Okay. Fine. Okay. So this is week 6 tutorial
4.
What is it? Maybe I'm not able to open it here. Can you tell me the question itself? It will be good.
Yes, I can.
Yeah. Yeah. Tell me.
Wait, I have written in my notebook. There are 4 black dogs and 16 brown dogs.
There are
running 4 black dogs.
Okay.
And 16 brown dogs.
1-6.
Yes.
Huh.
Are running on a ground such that no 3 dogs in a straight line.
No.
3 dogs
Huh.
in a straight line.
Okay.
Suddenly, 2 of the brown dogs started following one black dog, making a straight line, and the remaining 3 black dogs started following one of the remaining brown dogs. How many straight lines can be formed passing through at least 2 of the dogs?
Okay. Last. What is last? How many straight lines
can be formed passing through at least 2 of the dogs?
I'm okay. What is last sentence? I'm not able to. Can you just repeat?
Can be formed passing through at least 2 of the dogs.
Passing through at least 2 of the dogs.
Yes.
Okay. Okay. Fine. So currently there are no 3 dogs in a straight line, right? That is how
Yes.
they are. Okay. And what we have seen is one of the black dog is following 2
For making a straight line.
Yeah, true brown dog, right? Okay.
Two
And
brown dogs started following one black dog, making a straight.
two brown dogs and one
Two
black dog,
brown,
right?
yes.
One black and two brown. They are making one line. What is the next sentence?
Which question is this?
And the remaining three black dogs
Huh?
started following one of the remaining brown dogs.
So which question?
This is, I think, this one tutorial 6. Okay, you just give me a minute. Maybe I'll just see what is it. Okay, I'm slightly confused here. My screen is not visible or is it visible?
Can I share you my screen?
No, no, 1 minute. I'll just. Yeah, if you can, are you able to share the screen? If it is possible,
Let,
then
let me check. Wait a minute, sir. Are you able to see, sir?
yes, yes, yeah, fine. Then it's fine. Fine. Just a minute. Suddenly, two of the brown dogs started following one black. Okay, suddenly the three black dogs started following one of the remaining brown. Okay. Is this question complete? Like, are you able to see that side of the question?
When they are telling the question, then I have written this question in my notebook, sir. When they are
Can you just
speaking.
go ahead, like, because some portion of it is cut, right?
Yes, I have to
Okay, can you move
resume this
forward?
video.
That's fine. Can you move this video forward? Like, go ahead. Like, go ahead. Yeah.
Or more, I have to go ahead.
No, just little bit. Okay. 20 dogs are there. Okay, fine. That is okay. I think that the last sentence. How many straight lines can be formed passing through that? What is that cut part? The last one.
I have to resume this video.
You just listen it and tell me what is it. Initially, if you start that,
So what are
somebody
you
has
asking?
the last sentence, right? How many straight lines can be formed passing through what is it?
Passing through, at least two of the dogs.
At least two of the dogs.
Two of the dogs.
At least two of the, or like only two of like at
It's
two dogs.
the teacher which are telling this tutorial video, who is teaching this tutorial video. He told that it is not good for that passing through the dogs. Then he tell that passing through at least, please write, passing through at least two of the dogs. He had told.
At least, if no, I'm wanted to make
I
sure
am
that is
I
it at
am
least or is it passing through two dogs? That is the problem.
It's
See, at least two
at
dogs means,
least two of the dogs.
see, if you say at least, then that
Yes.
means you can have three, four, five, six, some like more than that, right?
So can you listen this video
Uh,
through my screen sharing?
okay, let's start once. Well,
Okay, okay. Then we can.
the audio will not come, right?
Are you able to listen my audio?
No, I don't
No.
think it will. I don't think I'll be able to hear. Maybe.
Okay. Then, sir,
Fine,
what
fine.
are
Okay, understand. So this is the problem, right? Maybe I'll ask one of the instructors. So there are two problems, right? This one, and I think we have activity. I think 11.6 or something, right? That one
yes,
problem also. Maybe these two problems uh, I will explain in the next class, right? Me or
okay, sir.
my colleague.
When will be
Whenever the class will be there, instructor led session will be there, we'll discuss. That will be the first two problems, right?
okay, okay, sir.
Okay. Okay, fine.
Okay.
I will just Yeah, I will just go through this video once again through my laptop and then tell you, because I'm
Okay,
not
sir.
sure about that word at least. Fine, right?
Okay.
Okay.
Okay. Please, sir.
Can I ask my question?
Which one? Yeah, tell me. Yeah, tell me.
General doubt, sir.
Tell me. Yeah.
Can I pause this
Yes,
in
yes,
share?
yes, yes, Suryansh. Yes.
Relative
Yes.
of mine has passed in May term re-attempt qualifier exam. Now the link for a September term is opened. Can she enroll in that or any other link is available later, sir?
That is, I think, operations related thing. But okay, let's. She has passed in qualifier in which term? May term. Huh?
May term re-attempt last month.
Last month she has passed. Okay, fine. So she can apply, I think, for September term, right?
Yes, sir.
Yeah, she can apply for September term, right? But cross check with the support team once. Just write down to that to support team. You do you have that mail ID?
Yes, sir. I know.
Support at the rate study dot, I think, ds dot item dot something like that, right?
Okay, sir.
Right? They will clear your query. Fine.
Okay, sir.
Okay.
Thank you.
Thank you guys. Maybe we can take some.
Sir, please conduct the revision sessions for week 5 to week
Yeah, sure.
8
Yes,
onwards.
Maybe
sir.
Yes.
yeah, I will take
Yeah,
And
that
also
session.
Poisson
the session
distribution.
was after
Poison will be
one.
covered with next session only. There is no problem. Poison, nothing is there, but yeah, it will be covered anyway. Revision sessions, I will do it in the next week, right?
Sir,
For
mainly for week
Yes.
after week 4. Mainly for after
yeah,
week
yeah,
4.
5 to 8, na 5 to 8 will conduct. Fine. One
Yes.
session will be there on for 5 to 8, and one will be 9 to 12. That okay.
Yes.
Okay,
Okay.
guys. Thank you.
Okay.
Okay, sir. Thank you.
Thank you, sir.
Thank you, sir.
Okay.